No, you don't keep on talking why you did not pass exam and all that. You forget. You have a syllabus with you now. You read line by line. What I need is I want you to read line by line.
Okay. Okay, sir.
What is the title of the paper Econometrics? No, you just read your syllabus.
Basic econometrics.
Yeah, econometrics, basic or advanced depends on who is the learner, who is the teacher.
Yes.
Econometrics. What is econometrics means? Don't define as per the text paper. I don't want that. Anybody can learn.
Okay. Okay. Econometrics means it is a combination of statistics. That is what I actually understood. From that, we can understand what all the terms are coming further.
You are a master student. Understood? You have to be master in that subject. You got it. So what is two words in econometrics? What are the two words?
Economics and measurement.
Matrix. Metric means measure.
Okay. Metrics means measurement.
Yeah. I am not going to measure the length using a scale now. Because economics cannot be measured with the normal meter, kilogram. How do you do? Price of an item, budget. These are all different terminologies which comes in economics, right?
Yes.
But it cannot be per day, in the afternoon, in the morning. It has to be over a period of time.
Yes.
In a month, in a year, how the price increases is what I wanted to know. Whenever there is large data, not one measurement, many measurements. Suppose you have fever. Okay. I want to check your temperature. Do the nurse will come and check only once or keep on checking every half an hour, 1 hour, 2 hours, 3 hours?
They will come and check once.
Only once in the lifetime? When you got sick in the hospital, will they check only once?
No. They will keep on checking after a few times.
Yeah. So many times when they check, what do? They draw a graph.
Yeah.
And the graph will tell whether the temperature is increasing or decreasing.
Okay.
Whether it is stable.
Yeah.
Same way, the product, if I am selling some item, I want to know the cost increasing or decreasing. So I will not measure once, I will measure many times.
Yeah. Yes.
When same thing many times when I do, that is called statistics.
Okay.
What is statistics? I want to know how much mark you got in some subject. I am not conducting one examination. I will conduct many examinations. Take an average. So one terminology, you have to write whatever I am saying. One terminology which you should be aware is average. I am not saying quantity, I am saying average quantity. So statistics is once I will measure, second time I will measure, third time I will measure, and many times I keep measuring. And I must check consistency. Oh, all the time when I am measuring it is equal, same style.
Okay.
Whether it is, suppose some product price is increasing and coming down. Oh, it increased and decreased.
Okay.
How did it increase? How did it decrease?
Okay.
This is what I like to know. I like to know how did it increase? How did it decrease?
Yes.
Okay. So if it increases, it goes up. If I draw a curve, every month, January, February, March, I make a line, x-axis. In y-axis, I am measuring. Oh, it is increasing. July, it was in the peak and it came down.
Yeah. Okay, yes.
So how do I measure statistics? Always I draw a curve and find out how is it getting up, how is it decreasing, how is it increasing. All these are my interest. I want to know how is it increasing, how is it decreasing. You understood what I'm saying?
Yes, DrTPS. Yes, I understood. Like how the variables did increase or how did it decrease?
This is what I want to know. Economics is how it behaves, not in one place. Maybe in a country, not for one product, for a multiple product. That is my interest, right?
Yes.
So I must know
Yes.
how is it functioning, how is it changing, how is it increasing, how is it decreasing. All these are my interest. Now you read. This is what is econometrics. I am going to understand how the change happens over a period of time for a large number of products. What is it happening? That study is measurements only, but not once. Multiple times I will measure and understand how is it behaving. Whether it is increasing, whether it is stable, whether it is decreasing. Behave means how is it changing over a period of time. Suppose transport cost increases. I know immediately the graph for the some other product also will change. So I can keep a relationship between transport cost, production cost. That is what is economics, right?
Yes.
Now you read the syllabus line by line.
Okay. Now I'm going to tell about introduction to econometrics. Am I audible, DrTPS?
Yes.
Okay. The term econometrics was coined by Ragnar A.K. Frisch, a Norwegian economist who shared the first Nobel Prize.
I don't want. Are you reading the textbook?
Yes, sir. Yes, DrTPS.
Did I not ask you to read the syllabus?
Sorry. First, I'm going to tell about simple linear regression model. First module.
What is linear regression? Okay. What is regression? What is regression?
Relationship between variables.
Yeah. What are the variables? Just now I told you, right? Time,
Yes.
number of products, which place,
Okay.
how much is the cost, how much is the production cost, how much is the selling cost.
Yeah.
So many variables. Variables means what are the things which are influencing and how is it influencing. All these variables I must study. That is what is regression. What is linear regression?
That means it is
Yeah.
affected by only
Yeah. No. The many variables may be there. But when I draw a line, it comes, the relationship comes like a line.
Yeah.
Not like a curve. Linear means line.
Yes. Yeah.
So it will not come.
Positive relation.
Yeah, either positive or negative. Linear means always line. Suppose if I take January and July and draw a curve, March exactly those line, March where is it hitting, that time that place only my price I can predict. Line require only two endpoints. 2 points are there, I can draw a line. In between I can find out. Suppose this is January, this is December. I draw a line. So July I can just take this measurement and say, oh, July this was the cost of the product.
Okay.
Because it's linear.
Yes. Yeah.
So instead of, I told you statistics is measuring many times. But sometimes I don't have to measure. Because I measure only 2 times. Straight line. Everywhere it is same price.
Yes.
Why should I measure many times? So what do? 2 years I did a model and then find the cost doesn't increase. Only from July it is increasing. Up to July the cost is same. There are many items like that.
Yes.
See, for example, you look at the garments, sweater, winter clothes. From February to August, no change at all because there is no temperature change. So September, October, November, December, it will go up. Because December maximum temperature down, people want that. So if I take a 5 years curve, I know February to July there is no change. July onwards there is a curve going up. So my study will be based on earlier year how did I study. Earlier how the behavior was. So the relationship between the cost and the parameters, cost and the time, cost and the production, cost and the product, all these I make graph and then keep it so that next year I can immediately say in October this will be the price.
Okay.
So regression analysis will help me to predict. And how is it? Linear regression, simplest one first. Then we will take something else later. There are many more things. Skew, kurtosis, so many words will come later. Statistics is very common with all that. Okay? Yeah.
Yes.
Yeah,
Yes.
tell me now.
First I was just telling about simple linear regression model.
Yeah.
And you made it clear. And now I'm going to tell about the nature and scope of econometrics.
Yeah.
So should I explain?
Yeah. Read the next line.
Okay. Nature and scope of econometrics. Then there comes economic theory and
So nature
economics.
already I told you. Scope also I told you.
Yes.
Because you want to predict, that is useful. See, all these small lines will be explained in your textbook. When you read, it will become more and more clear for you.
Yes.
Yeah.
Okay. The economic theory and mathematical economics.
Yeah. Economic theory. Economics, there is a theory. What is the theory? The product cost depends on the budget. It depends on the tax. It depends on the transportation. It depends on the trade. It depends on the different material available, manpower available, mission available. All that depends on, it will define the product cost, price, everything is defined. And microeconomics, macroeconomics, all these will come. In every item when I wanted to use, I used to have numbers. Without a number, there is no economics. So that is what is called mathematics in economics or mathematical economics. Yeah.
Economic theory and mathematical economics, as just now you told.
Yeah.
And methodology of econometrics. Next one.
So methodology is statistics. I am going to take this example, like take a sample. I cannot do every day. So what do? Every week I will do sometime. But gold cost, every day, morning and evening gold cost. You can see in the report, how does it say? Gold cost was morning 10 o'clock, this is the cost, evening 5 o'clock, because it varies too fast.
Okay.
But I am not going to do it for clothes. Once in a week only.
Okay.
So what are the methodologies which I apply to predict my economics?
Okay.
Yeah.
Next, uses of econometrics.
Very clear, no? All these is what determines my GDP. How is the product cost increases? That will tell me the GDP. GDP will tell how much extra PF, provident fund I have to get. How much is my inflation rate? How much is the salary hike to be provided to people? The international cost of some of the oil will decide how much is to be charged for petrol.
Yeah.
Everything depends on what is predicted. That is a model, economics model, which is working on econometrics. That will decide how much is the life of people in this world.
Okay. Now I understood. Uses of econometrics.
So what are your teachers doing in the classroom? They don't explain like this.
So they are, DrTPS, they are explaining by reading each and every sentence and then explaining that. They are not using any good examples, so they are not teaching like this actually.
Okay.
To be honest.
Yeah.
Then, if they are taught like this, maybe many students are there like they could come out in this exam.
Don't worry. Now you can teach everybody.
Sure. I
What you should do is, that is why I want generally, when you have, this is going to get benefited for many people.
will. Yes.
So
Of course.
you explain by reading your textbook, understanding better. You explain. I taught economics for law students. That's why I don't want to look at it. I taught mathematics. I taught regression. I taught statistics. I taught economics.
Now,
Syllabus. Next line.
okay. Next one is concept of PRF, population regression function.
Population regression function. Now assume that I have only 10 people to purchase,
Okay.
or I have 100 people to purchase. Don't you think that there is a product cost, purchase cost, transportation cost, everything get benefited based on the number of people who are using it?
Yes.
So definitely one of the component of economics is population.
Okay.
How many people? How much large product, how much quantity I have to produce? The production cost and the economics, the benefit of economics. Benefit of economics depends on quantities, whether it is small quantity or large quantity. So population. Okay, then your sound is gone. Tell me.
Should I explain what is PRF?
Yeah, tell me. What is it?
Population regression function. So, sorry, DrTPS. I can't tell that.
No, you tell what you know. I will reword it.
I know an equation for PRF.
Yeah, tell
that
me.
is.
What is that?
Now I understood, sir. Now I will tell. It is the prediction of a y variable or dependent variable on the basis of the known values of independent variable.
What is dependent
That is
variable? What is dependent variable there? Example.
Example, about price and consumption, income and consumption.
Okay. What is independent variable?
Sorry.
What is dependent variable? What is independent? What is the formula? You tell me. PRF.
Yi equal to beta naught plus.
What is beta naught?
Parameters.
What parameter?
Actually, I don't know what it depicts.
No. What I am saying is, you should find out what is beta naught. There is an explanation in the textbook. Beta naught plus
beta 1 xi plus ui.
Yeah. So one will be the basic cost. Second will be how much times it has to increase. The third one could be how many other quantities which may be resulting without unpredictably, which causes. Probably some material which I am buying, it may have unpredictability. So all that together will tell me what is that exactly, the cost and the price. Therefore that will be the fraction that you have to study. So there is a relationship between what is predictable, what is unpredictable, what is deterministic, what cannot be determined perfectly. All that relationship is what will be shown in the formula.
Okay.
And what is proportional means, when I am increasing the number of products, the cost will come down. Because transportation, whether I have to take 1 fridge or 10 fridge, the number of fridges are more, number of items are more. Suppose I have to send this to somebody. Suppose I have to send 10 pens to somebody. The transportation cost will not vary, no?
No.
Yeah. Therefore, some parameters, the production cost of this will vary, but the transportation cost is fixed. So there are some fixed variable, there are some variables which are dependent on the number of products. The relationship is what we will put in the formula.
Okay. Yes, sir. Then concept of PRF. Just now you explained. It is clear. Somewhat, yeah, it is clear.
Yeah.
Got it. Then significance of stochastic error term.
What is that?
Stochastic, I think.
Yeah.
So I didn't pronounce it.
Stochastic. That is perfect. See, some
Okay.
variable. I told you the cost of this is understood.
Yeah.
But I don't know if this product is going to be from one railway station to another railway station. I know exactly fixed costs. But when it comes to Thrissur, you will have to take an auto rickshaw to take it to bus stand.
Okay.
Because bus is not coming at the railway station, right?
Yes.
But some places, bus stand and railway station may be very close. So you don't have a transport cost of auto rickshaw in some place. In some other place it is there. So what is the cost which I input as auto rickshaw expenses? Depends on one place to another place without prediction. I don't know whether it is everybody can make a model for this. No, it is not possible. Depends on place, depends on day, depends on time. Suppose it's the morning time I am taking an item and my delivery has to be at 10 o'clock to 12 o'clock. I can take it. But if somebody asks me a product which is to be delivered in 2 hours is my job. But it comes at 11 o'clock midnight. Train came late. What do? I will have to pay extra amount for the lodging, probably taking a taxi and taking it. So unpredictable things are called stochastic.
Okay.
They are called random.
Yeah.
Another word is called random. What is it called?
Random.
Yeah, random variable. Random variable means I don't know how does it behave.
Okay.
So the example is, assume that I wanted to take a lottery. Suppose if I put 10 items and then take a coin out of it. What I get selected is called random. Unpredictable. What does it mean? Unpredictably it happens. So random, unpredictable, nobody can decide this is how it is going to be. Such items are called a stochastic process. Suppose you have a die and then throw it. Whether one dot will come or 6 dot will. 1 dot will come or 6 dot will come. Can anybody predict?
No, never.
So that is called a stochastic process. Random process. It's also called random process.
Random process.
Okay. So in economics, where does it come? Economics it comes because sometimes I cannot predict how there is a variable transportation cost. But I don't know whether transportation is always fixed or not.
Yeah.
Because it is not, I cannot say, oh, distance is 10 kilometer, then transportation cost is 20 rupees. I cannot tell this. It depends on which city, what is the transport available, what time I am going to supply it. So many parameters are there which are unpredictable, and any unpredictable thing is called a stochastic. Got it?
Yes, sir. Yes, totally. Yes.
So see, what you should do is while writing economics in such examinations, suppose there is a word called stochastic, explain stochastic applications in economics. You must write like this with a lot of examples, paragraph by paragraph, underline the technical term stochastic, random sample. These are called random sample. Unpredictable samples. You write very lavish like this, definitely you get good marks. That's another trick of getting good marks. Yeah.
Okay. That is clear, extremely clear. Then the SRF.
What is SRF?
Sample regression function.
Huh?
Sample regression function.
Yeah. Now I told you I am not going to measure temperature putting the thermometer here every moment. I am only putting every 1 hour.
Yeah.
Correct. So each time
Yes.
when I do it, it is called a sample.
Okay.
So how am I going to draw graph? Do I do it when price of an item? I will do January, February, March, April. When temperature is taken, do I do every month? No. When I have fever,
No.
I will measure it every 1 hour. Suppose somebody's temperature is too high. What do? I will do it every 10 minutes.
Okay.
So my sample also is considered how every time it behaves. Regression is how is the behavior happens. Whether it is linear regression, whether it is a curved regression, but then I cannot measure it every 1 hour and then say, oh, between these 1 hour temperature varied normally. Not necessarily. In between it would have gone up and
Yes.
then come down.
Yeah. Yes.
Suppose I have given cross in medicine in the morning 8 o'clock. And then after some time I will see the temperature comes down. If I don't measure it, how do I know up to what time the effect is there, then it is going up? Because after some time I am measuring, again the temperature is high. But then I will not be able to predict whether the effect of my paracetamol is there or not, because in between it came down and gone up. So if I wanted to know the effect of this parameter, the tablet is the effect. I want to know the tablet effect. I should not measure every 4 hours. In between every 1 hour I must measure. So my sample is how many times I am going to measure. How many times I am going to measure depends on the parameter which I do. Therefore it is sample regression function.
Sure. Okay. So I start on another. Now, problem of estimation.
Yeah. What is estimation? I know something today. I know the cost of X, Y, Z. I know the cloth cost. I know the stitching cost. I know the rent for my shop. I know the rent for my tailoring machine. I know each item which I have to put. If everything I know, I can estimate what can be the cost of a ready-made shirt. I know how much percentage of profit somebody wants. Say 30% profit. Everything together, I can estimate what will happen, right?
Yeah.
So I am estimating. From the non-parameters, which are the parameter? Stitching cost, cloth, button, transportation, rent, tailor's cost, and everything I have to add together. Packaging cost, putting it together, everything I will add. Then I add some profit and then say this is the cost of the product.
Okay.
So I am estimating. What is the word which you said? Estimating.
Parameters.
Yeah. Now I know the parameters. I know how to estimate. Then
So you just told about estimation, right?
Yeah.
Okay. Estimation of parameters. For that, you use the example of stitching and all, stitching cost, button transportation. If we add everything, we will get the estimation.
Yeah.
So that is what problem of estimation is depicting.
That's it. Simple, no?
Yeah. It is simple like this, but when I
Don't tell.
know.
That's all gone. Old cases, forgotten.
Okay. Next, can I move to the next one?
Now one chapter is over.
No, there are some more.
Yeah, read that. Read. As far as we can finish, at least one portion of your syllabus can be done. You study that, and then we will have another sitting, and then I will teach you the next one.
This is a new topic. Method of ordinary least squares.
Yeah. What is least square? Suppose I have got one. This is my cost. No change at all. Say.
Okay.
Now after some time, now you have to look at what I am saying. This is the line. I have got a x-axis and y-axis. This is how my price increases.
Yeah.
Now what has happened is, one day the price can be lower, another day it can be higher, another day it can be less or more, like that. No. So this is the average cost. So at each point it can be either up or down or up or down or up or down or up or down. Now if I take this distance, subtract from the nominal predicted one. This is my prediction. From January to December, this is how the price increased. But when I measured in February, it was less. March, it became more. April, it became less. Now if I take the distance from here to here, it will become positive. Because from the nominal, I am subtracting the actual cost. But here, actual to nominal, I am not doing. Nominal to actual only I am doing. It will become negative. It will become positive. It will become positive. Here negative, positive, negative. If I take an average of all that, what will happen? Everything it will get cancelled and then say there is no change at all in the cost. So then actually there is a change because January it came down, February it went up, March it came down, April it went up. Actually it was like a zigzag. But if I take an average, it will show that there is no variation at all.
Yes.
Because one is negative, another one is positive. Another one is negative, positive. It may get cancelled. If at all it is not cancelled, some place it will show, oh, this much is the cost. It will show only one small change in the price. Actually, there is no small change. There was great change. Sometime it came down, another time it went up. So how do I show this? Method is least square. I find the distance, square it. Suppose original cost of the product was always 10 rupees. One time it became 8 rupees. Oh, immediately I will say price came down 2 rupees. But I am not noting it as 2 rupees. I will do it as 4 rupees. Square. Next time it increased to 3. Suppose if I take an average of -2 and +3, it will show only 1 rupee change was there.
Yeah.
Actually, it is not 1 rupee change. Actually, there was a change from 2 rupees to 3 rupees high. 2 rupees less, 3 rupees high. 5 rupees difference is there.
Yeah.
So how do I make this to understand statistics? There is a big trick called least square. What is the square? Find the nominal one. Instead of 2, I will write 4. Instead of 3, I will write 9. Now 4 plus 9 is 13. And take a square root of it. So when I take a square root, it will show, oh, there was a variation. Because negative will become positive when I make a square. -2 square will become 4. 2 square is also 4.
Yeah.
So it is going to show me how much it is thrown out of the average. Whether it is less or more, I don't care. I want to know how far it is from the average.
Okay.
That is why it is called least square. So in statistics, in practical cases, I should not just find the difference between the nominal and the other one and average it and say there was no difference, everything was perfect, no variation will be the answer. To avoid that confusion, what we do is take a square. That is why it is called the least mean square distribution. Suppose your weight needs to be understood. You are measuring when you are 20 years old, your weight was 60 kilogram. 22 years 60 kilogram. 25 years 60 kilogram. Does it mean there is no change in your weight?
No.
In between there may be change. So how do I measure it? I measure one day and see, oh, there was the 60 became 62. Another day it became 58. So I have to make the square, make that square. Otherwise 62 and 58, take an average, again it will become 60.
Okay.
Variation will not be shown. I don't want that to happen. I want variation to be shown. If there is big variation or small variation. So I am squaring it. So there is a 4 difference here, 4 difference here. 4 plus 4, 8. Square root of that. Oh, almost 3 difference was there. That is how I predict. This is a method used in statistics, least mean square distribution method, to find out actual variation, not average variation. Average is not a good terminal when there is a fluctuation. In economics, we learn about fluctuation. Price fluctuates. So temperature fluctuates. Cost fluctuates. If I want to study fluctuation, always use mean square study. And when I do square, I have to take root. Square root. The root means square root. So I am doing square root of all the squares added together, then take a square root.
Okay.
And find out how much is minimum, least mean square. So from the average, which is a line, average is not a number, it is a distribution, average distribution, how much it is gone up and down. Find out that and then see how it fluctuates. For that study, I use least mean square distribution.
Okay.
Yeah.
Okay. So that is ordinary least square method.
Yes.
Yeah. So next topic, assumptions underlying the method of least squares.
I already explained what is the assumption. Assumption is it is not always up, it is not always down, it fluctuates. Fluctuation is the word to be used.
Okay. I'm sorry, I am writing the notes when you tell.
No problem.
That's why it's. Then, properties of estimators.
What is that?
Properties of estimators.
Yeah, which are the estimator? I want to know how it behaves. Therefore, what do? I keep adding lot of different methodologies like behavior, whether it is increasing all the time, whether it is decreasing all the time. These are all
Okay.
these are all based on how the distribution is. So there is a method called least square fit method, in which mean square distribution, different distribution, whether it is going up or down, I am going to study based on the way it is distributed.
So it means like whether it will increase or decrease all the time, that behavior.
Yeah. Suppose there is a distribution. The mean square is like this. I am going to see whether it is going to be up or down. So mean square distribution, how the behavior of the product is distributed, how the price distribution happens. These are all done through statistics.
Okay.
Yeah, next word.
Okay, Gauss-Markov theorem. Next one.
Gauss-Markov theorem.
Yeah.
Yeah. I don't know what does it mean. You have something there, then you can explain to me. I don't know by heart of.
Oh my god. I didn't reach I was just studying till that. And I was taking.
Actually, Markov is a distribution function. Generally, what is done is, in the least square estimate, I told you there is a line, how much it is varying. Okay. Yeah. So this estimate is done whether it is, there is a price every time it has gone down. What is that distribution, whether it has happened with some bias? What is the bias? The bias can be based on the quality of the product has come down.
Yeah, okay.
Then what will happen? The cost will come down. Or maybe no buyers are there. Therefore, I reduce the cost. Okay. These are all biased items. So my parameters are not stable. My parameters qualities are not very, very perfect all the time. If it is, I need to change it based on the quality of the parameter. Whether I am biased based on the quality or not is the question which I should ask. So the difference, the variance from the mean square going up or down, is it because of a biased problem or unbiased problem? So the least square method has some conditions. So those conditions are what is actually explained by Markov. Okay. So whether this fluctuation what is happening in the market is based on some bias. The bias can be a tax, bias can be a transport cost, bias can be a product cost. It has got many factors. So you look at each variable and identify how is it affecting. It may not be linear. There may be a bias which has happened. Bias means something has influenced it. Unbiased means without influence. So actually my prediction should be without influence. All these are used for predictions. Yeah. So I am biased, then prediction can be wrong. Unbiased means predictions will be correct. So you read the theorem and understand now. With this concept in mind, you read. It will become clear for you.
Post-Markov theorem.
Yeah.
Okay.
These are all part of normal statistics, regression analysis, Gauss, Markov, measurements. So the first content is over, first paragraph in your syllabus.
No, there are, I think so, 6 terms.
Yeah, that term only you read. The rest of the things you
Coefficient.
expand reading, you do it later.
Okay, sir. Okay, DrTPS.
Uh.
Next is coefficient of determination.
Yeah. Now what do I do is, I make a prediction. See, always line means, what is the equation of line? Y is equal to mx plus c. So you write y is equal to mx plus c.
Y equals mx plus
C. That is the equation of a line.
Okay.
Okay. So
Okay.
y is equal to x. Then m becomes 1. What does it mean? Oh, there is no prediction. Straight line. So my y is equal to mx plus c. M is called a coefficient. That will tell me the slope. Suppose m becomes 0. Then it will become y is equal to c. Y is equal to c means in the x-axis a line, straight line like this. Y is equal to m is equal to 1 by 2 means it will have a different slope. 1 by root 2 different slope. So this is actually the slope. Whether the line is parallel to x-axis, no cost difference. January to December, same cost. Line will be like this. Suppose it is increasing normally, it will be like this. It is increasing too much, then it will become like this. The slope is the angle. So the coefficient m is what you are saying. What is coefficient m? What is the word which you used?
line equation. No, y equals mx plus c.
No. You read your syllabus. What does it say?
Coefficient of determination.
Yeah. So the coefficient m will determine whether the cost will be normal, whether cost will be increasing. So that coefficient m is determining.
Okay.
Oh, it determines how the slope is. Slope of the line is line. The increase, stable, decreasing. Suppose it is like this, the cost is reducing. It is like this, cost is stable. It is like this, cost is increasing. So who will determine this?
M.
The m will determine. That is called coefficient. M is called, you write there, m is the coefficient. Now when you get a question like this, you must immediately write y is equal to mx plus c. M shows the slope. M is equal to 0, it will be a straight line. M is equal to negative, the slope is down. M is equal to positive, slope is up. The product cost is increasing, product cost is reducing. Everything determines the value of m. Therefore, it is called the coefficients of prediction, or coefficients how the behavior.
It's very easy to learn like this.
If you have a good teacher, it is easy.
Yes. So can I go to the next topic?
That chapter is over. That first
No.
paragraph is over.
No, it's not.
Yeah, then move next. Once you are satisfied, move to the next.
Sorry, Dr. TPS, it is written coefficient of determination, comma, R square.
Comma?
R square.
What is R?
It is a regression.
That is what I am saying. The change, see the square root difference. Suppose it is like this, it varies. Suppose it is like this, it varies.
Straight.
Suppose it like it varies around it. Yeah.
Okay. Then normality assumption.
Yeah. What is normality assumption? I believe the cost of the cloth is not changing, only human cost is changing. I believe transport cost is not changing. I believe something is normal.
Okay.
Assumption is when I do a study on, oh, the tailor's cost is increasing, then I should believe first cloth cost is not increasing. Otherwise, it will not become non-linear, it will become non-linear. Too many parameters will come. I am only studying one parameter at a time. So when I study one parameter at a time, rest of the parameter I freeze.
Yes.
That is what it says. Normality. I decide that there is no change at all. Nominal behavior. That's the assumption which I do. It's an assumption, right?
Yes, yes.
Yeah.
So next one, hypothesis testing.
Yeah. What is hypothesis? I first decide when I reach in Thrissur railway station, there is auto rickshaw available. That statement is a hypothesis. Under the hypothesis only I am computing the cost. But when I reach there, auto rickshaw is not there, only car is there. So the price changes.
Yeah. Yes.
So my hypothesis is what I presume, what I think is there. All computations are done on assumptions, on hypothesis, assumptions, etc., etc.
Okay.
Yeah.
Okay. Okay, that is hypothesis testing.
Yeah. So I test based on the hypothesis. First my test is, oh, the price is always straight increase like this, based on one parameter it increases like this. I test whether it is correct or not. Oh, it is not working. Then what do? I test with another hypothesis.
Okay. Oh, okay. Okay. T and F test.
Yeah.
Hypothesis testing. T and F test, P value.
There are so many tests like that based on the parameters. Now if you read, it will become very clear for you.
Okay, sir.
Yeah.
Then practical versus statistical significance.
Yeah. What is practical? What is statistical? I predict something. Last year it was like this. This much rain was there, and therefore this many umbrellas were sold. But every year it need not be. Practically it can be different. Statistically it can be different, right?
Yes.
I know from June to July, number of umbrellas sold in Kerala, Thrissur town is this much. But this year from March onwards rain came. Practically it is different.
Yeah.
There can be difference. One is practical, one is statistical.
Okay.
Statistics is based on my predictions, based on the earlier occurrences. You should use those words, occurrences. That becomes a statistics.
Now, prediction.
Whether the first stanza is over, you must stop.
Method of maximum likelihood.
What method of maximum likelihood? What is maximum likelihood? What can happen? Oh, maximum that umbrella can be sold this many. How does it happen? That is the prediction.
Yeah.
So up to that prediction, what I do, what are the chances of my prediction being correct is what is being checked. That is maximum likelihood of my hypothesis, my parameter, my computation, my statistics tally with the practical thing.
Okay.
Yeah.
Then last one is maximum likelihood estimation of two variable model.
Estimation of
Two variable model, maximum likelihood.
now what we said is one variable. That is why only one was taken. Now you do with the two variables, two parameters, right?
Okay.
So it will become little more involved.
Okay. Our first module is over.
Wonderful. What you should do is study this perfectly.
That's great, actually. And I got this, sir.
Okay, so you study this perfectly, then we will come back. I have got another meeting at 5 o'clock.
Okay, sir. Sure. Thank you so much, sir.
So study well, and you are so blessed you are able to connect like this, correct? So many people in this world are not able to connect.
Yes, yes.
Is it not?
I'm really blessed.
And you are also not in contact with me for long time, but when you need a real purpose, you are in touch with me.
It's actually God's grace.
This is a great fortune. Use it perfectly, study well, and you must be very happy that oh, I am able to study well. Now you see, 1/5 of your syllabus is over,
Yeah, sure.
and today you can finish this. Tomorrow you can take another 1 hour and then learn from me the next chapter. Now if you look at this, every chapter becomes so simple for you. So you must study this perfectly, then look at the syllabus, identify the questions in this pattern, write an answer, elaborate without conjuice.
Okay.
You will do well.
Okay, sir. Thank you so much, Dr. TPS.
Why do you want to thank me? You are doing well. That itself is the great thing.
Okay.
Okay?
Okay.